All right. So, my name's Alex Kale. I'm a second-year PhD student in the Information School at the University of Washington. And I'm going to present on some work that I did with my advisor, Jessica Hullman, who's at Northwestern University, and Matthew Kay at University of Michigan. So researchers often make hard choices about how to collect, analyze, and present information. Together, let's consider the competing goals and incentives that influence this decision-making. Can I get a show of hands? How many of you have ever set out to write a related work section for your paper with aspirations to thoroughly summarize all of the critical prior works related to your project? Should be most of us, right? Now, how many of you have ever failed to achieve that great related work section that you set out to write because of constraints on your time leading up to a deadline or constraints on the available space in a paper? Right. So we argue that researcher decisions are characterized by such tensions between idealized goals and constraints in practice. Often the optimal choice of analysis is unclear, and the researcher must develop a rationale for the decisions, sometimes principled and other times arbitrary. Prior work refers to instances where researchers use their discretion as researcher degrees of freedom. And although this flexibility in analytical decision is often framed as an issue of methods or incentives, in our study we investigate it as a design problem. We interview researchers to better understand their decision-making practices, and we ask how we can design interactive systems to support researchers in making these analytical decisions. To investigate researcher decision-making, we focus specifically on the context of research synthesis. Research synthesis often entails a systematic review of the scientific literature on a topic. That is a structured process for defining a question, querying the literature, and coding each article in a review. Sometimes, in addition to systematic review, research synthesis will involve quantitative aggregation of evidence through meta-analysis. That is a procedure of collating results across studies and combining them into an overall estimate of effect size through a statistical model. By effect size, we mean the standardized quantitative estimate of the impact of some intervention, say mindfulness therapy, on an outcome of interest, say incidence of diagnosed mental health disorders. The end products of research synthesis are often a written report of findings and process details, as well as a recommended course of action, especially in cases where research synthesis is conducted within an organization in order to support evidence-based decision-making. I want to point out that research synthesis is distinct from research in general in that it mostly involves a recombination of prior work to address a practical question rather than a brand new novel study. So to investigate researcher decision-making practices, we conducted open-ended conversational interviews. The interviews were designed to get researchers to discuss their analytical decisions through specific examples. We used a combination of snowball and convenience sampling to recruit interviewees who regularly use systematic review and meta-analysis to solve practical problems within their respective organizations. We recruited 11 professional researchers in total. That's 4 professors and 1 postdoc at the University of Washington Medical Center who study a variety of topics, 2 PhDs at the Seattle Veterans Affairs Medical Center who study treatments for post-traumatic stress and substance use disorders, and 4 scientists at the United States Naval Air Warfare Center Training Systems Division who evaluate various trainings for soldiers. Now, we don't claim that this sample is completely representative, but we do think that it reflects the high variability among applications for research synthesis. The interview guide was a list of topics of interest, and we would first broach each topic by asking, did you ever, for example, exclude studies that you considered in a review from a meta-analysis? We would then ask them to describe a specific example in order to elicit contextualized descriptions of research synthesis practices in retrospect. We would then use these concrete examples they provided to ground further discussion about how they made decisions. And we grouped the topics of interest in the interview guide by the stages of the research process that we discussed earlier. In our analysis, we identified 480 decisions that interviewees mentioned. We also identified 21 different reasons that researchers give for their decisions. And in subsequent analysis, we grouped these reasons into 6 motivating factors that drive researcher decision-making. To help us consider the design of interactive tools for research synthesis, we kept track of user needs around decision-making, especially when users explicitly stated the need for improvements over the tools they currently use. Now, all these decisions, reasons, and needs emerged through open coding. We also integrated theories from related prior work to deepen our analysis of researcher decision-making. To understand our decision analysis, envision the analysis process as a series of decision points, each potentially influencing subsequent choices and analytical results. To borrow a metaphor coined by the statistician Andrew Gelman, we can think of the research process as a garden of forking paths, where each decision is like a fork in the road. So, how do researchers choose which path to take? Thankfully, we can borrow from a review of a large body of literature on judgment and decision-making conducted by Lipschitz and Strauss. They identify 3 broad strategies that people use when making decisions under uncertainty: acknowledge, reduce, and suppress. The first strategy researchers could use is to acknowledge uncertainty. And they might do this by exploring alternative analyses and thinking about how to preempt problems that they might encounter later on. For example, consider this quote from a researcher. We'll call him Joe. When the search term for a database query in a literature review isn't clear, it's a nightmare. It's this sort of ongoing iterative process of trying out different terms. And the conversations with collaborators have been the best way to narrow the scope of the search, in my experience. The behavior described in this quote is illustrative of 2 themes around the use of acknowledgement. One, that researchers explore their options because they are motivated to perform a comprehensive analysis. And 2, that rationales for planning decisions often emerge through interpersonal communications. If these rationales are documented at all, it is often in the form of informal note-taking. We are interested in how interactive systems could more explicitly represent this iterative search over a set of queries and the social process by which decisions are made. In our interviews, we see acknowledgement not only as scoping early on in the research process, but also later on. For example, when interviewees describe using caveats to communicate with stakeholders about potential limitations of their analysis. Acknowledgement is an important part of planning and communicating, but in order to construct an analytical result, researchers need to make more definitive choices as well. One strategy researchers can use to choose among possible analysis paths is to reduce uncertainty. They might follow a set of rules or procedures in order to systematically select what they believe to be a reasonable analysis. For example, by using inclusion criteria to scope their literature review. This kind of thinking is necessary in order to produce a result, but researchers really have to be cautious because not all instances of the reduction strategy are equally justified. The alternative strategy for making definitive choices at a decision point is suppression. Suppressing uncertainty is characterized by ignoring possibilities, gambling on potentially misleading analysis paths, or rationalizing why potentially better alternatives are not feasible. Suppression is really the least desirable decision-making strategy, but sometimes it is unavoidable if the researcher needs to proceed with their analysis under less than ideal circumstances. In our interviews, we found that there's a blurred line between reduction and suppression of uncertainty. Although there are well-defined best practices for research synthesis, interviewees often describe shortcuts and compromises to accommodate constraints such as limits on available time or evidence. For example, one best practice is to collate evidence across studies in a review by collaboratively filling in a spreadsheet called an evidence table. Consider this quote from a different interviewee, we'll call her Anna, describing whether she would consider using an evidence table. As far as using it every time and pulling out every piece of information, I would literally have to have an intern do that for me because I don't have time. We are interested in how software could make systematic extraction of information into evidence tables less cumbersome for researchers like Anna. Now, you may be wondering if coding decisions as suppression versus reduction was simply a value judgment on our part. We try to avoid bringing our own beliefs about appropriate procedures into play, and instead we relied on participants' stated or implied ideals in order to decide whether or not a decision should be considered suppression, at least for the purpose of our analysis. We found that the motivations behind researcher decisions are often in conflict with one another. For example, consider another quote from Joe. Initially, I wanted to include this topic in my review, but there's only a couple studies for which that is relevant, so it seemed like it was cleaner to just exclude. When he says cleaner, Joe seems to be concerned about making inferences from a small sample. Interestingly, a different researcher described a similar situation where she made the opposite decision because the group of 2 studies that she was examining were so vitally important to address her research question. So through these 2 stories, we can see how the drive to address research questions and concerns about statistical power are in tension with one another in decisions about study inclusion. We're interested in how interactive systems could represent the trade-offs between competing motivations. So our analysis of interviews point to aspects of the research process that should be represented in interactive systems. And for the remainder of the talk, we're going to discuss some ideas about what HCI researchers can do to help with decision making and research synthesis. For starters, we found it helpful to formalize the problem in order to ground our thinking about how to design interactive systems to support research synthesis. We proposed framing analytical decisions as utility maximization. Utility theory posits that the expected value of a given action, for example, a gambling strategy, is determined by the consequence of that action, for example, the payoff of that gamble, and the subjective value that we place on that consequence. If we apply utility theory to researcher decisions, we treat actions as possible analyses paths, where each decision alternative entails an alternative path. We treat the consequences of decisions as the accuracy of analytical results produced by that path. Note that in the formula above here, we characterize the consequences of an action A in light of a state of the world S. This is to say that the accuracy of a particular path is determined in reference to the true state of the world. But if we knew the true state of the world, there would really be no need for analysis. So this means that researchers must rely on proxies to judge the consequences of their decisions, because the true consequence of each path is unknown and perhaps unknowable. These proxies might be their subjective sense of confidence in their analysis, or how the results from different analyses compare to one another. Researchers also appraise the consequences of their decisions through a value function, which represents their rationale for decision making and how they respond to these tensions that we've been pointing out between goals and constraints. Importantly, despite the fact that utility is a formal model, the value function accounts for the fact that rational and well-intentioned researchers choose different analysis paths depending on their priorities. Utility theory posits two fundamental requirements for decision making, which we can draw on to think about the design of interactive systems. To ensure that they maximize utility, researchers should be able to compare the consequences of their actions, and they should be able to identify the value that they place on those consequences. So we found three challenges and corresponding opportunities for designing support for research synthesis. In our interviews, we see that researchers are naturally inclined to survey multiple possible analysis paths, in part because they're driven to conduct a comprehensive analysis. However, in practice, they need to commit to a plan and implement it if they're going to achieve a finished analysis in a reasonable amount of time. Consider this quote from our Navy scientist, Anna. We'll have suggestions for how different types of analysis, for these different types of analysis we can conduct that might help us split the hair a little bit differently to give us additional information that we can then decide, okay, what is the best way to report on this now that we've tried it both of these ways? The notion of splitting the hair a little bit differently to gather additional information might strike us as rigorous. And at the same time, the notion of choosing what to report after trying multiple analyses might strike us as behavior akin to p-hacking. This dilemma is illustrative of a particular challenge for software design. How should we support researchers in trying multiple analyses? One solution proposed by prior work in multiple statistics is multiverse analysis, which is essentially trying and reporting multiple analyses. And existing tools do not really support this kind of analysis without the programming of custom analysis scripts, which limits the accessibility of multiverse analysis for researchers who don't code. From the perspective of enabling utility optimal decision making, comparing multiple possible results through multiverse analysis could help researchers calibrate their sense of the consequences of their decisions. So, for example, when different analyses paths lead to convergent results, the researcher may choose a path that trades off accuracy with other desirable properties like time or resources saved, or maximizing consensus or interpretability. Alternatively, when results are highly variable across analysis paths, researchers should exercise extreme caution, and they should probably report multiple analyses if possible. Another challenge for design is that despite best practices which emphasize consistent ways of processing evidence from studies, researchers seem to document the rationales of their decisions inconsistently. If researchers document their reasoning at all, it is often distributed across personal correspondences, notes, and various work documents. And there are multiple reasons for this, among them the fact that researchers have limited time, and the fact that researchers working within organizations sometimes do not have the agency to reshape their objectives in light of available evidence. From the perspective of enabling utility-optimal decision-making, inconsistently documenting rationales may contribute to difficulty weighing motivations for the purpose of making these important value judgments about the consequences of decisions. One possible way to address this challenge might be a system of user-defined and reusable flags that researchers could use to attribute their rationales for various analytical decisions. And these might be similar to custom codebooks in Rayan, shown here. Rayan is an existing tool for systematic review, but there are some open questions here. One, how to make this kind of feature flexible while at the same time ensuring that researchers use it consistently. Two, how to make such documentation minimally cumbersome for researchers. And three, how to represent trade-offs when competing motivations suggest different courses of action. A third major set of challenges are around how researchers present uncertainty information to stakeholders. Consider another quote from an interviewee in the Navy describing what decision-making officials expect from uncertainty communications. He says that decision makers do care about the fidelity of the data, they just don't want a chart on it. However, by de-emphasizing this information to satisfy a lack of tolerance for ambiguity and risk, researchers may be suggesting that inferences have greater credibility than they do. We argue that tools should provide researchers with communication techniques which counteract decision makers' specific aversions to uncertainty. For example, what if stakeholders are averse to uncertainty because they might misunderstand probabilities or statistical models? Well, prior work in psychology, statistical reasoning, and data visualization suggests that people reason about uncertainty most accurately when it is framed as frequencies of events rather than probabilities or summary statistics. For instance, visualization techniques like quantile dot plots and hypothetical outcome plots show possible outcomes as discrete graphical objects. And this enables users to reason about uncertainty by counting the proportion of dots, for example in this image, which represent desirable or undesirable outcomes. Additionally, frequency framings have also been adapted in interfaces for eliciting users' predictions about effect size and reliability, so as to deepen their engagement with uncertainty information. Now, alternatively, if stakeholders really just want a clear yes or no answer and perhaps find these distributions overwhelming, it may help to emphasize point estimates, or alternatively, researchers could propagate uncertainty in the estimated effect distribution to derived measures that may be more closely aligned with stakeholder values, such as cost or time saved. So there's a large body of work on uncertainty communication to the public and for decision making, but this work is not well integrated with the design of interactive systems. It has not absorbed more recent findings such as those on uncertainty visualization, and it has only been marginally codified in researcher best practices. So one of the goals of the recommendations of our paper is to begin charting a research agenda for drawing together these bodies of research in service of interactive systems for data analysis and research review. Some questions we plan to address in future work on interfaces for meta-analysis concern how researchers extract effect size information from a heterogeneous set of studies, how they reason about the extent to which these effects are comparable, how researchers conceive of the meaning of the aggregated effect resulting from a meta-analysis, and how to ensure that their intuitions align with the actual statistical meaning of these estimates. And we think that interactive systems have a key role to play in supporting critical thinking and experimentation around questions like these. So to summarize, we found that researchers conducting research synthesis need interactive systems which support them in trying multiple analyses, representing the reasoning behind their decisions, and communicating uncertainty and analytical results. In the paper, we present a more extensive set of opportunities to address these design challenges, as well as a thorough exposition of results. And you can check it out by taking a picture of this QR code. Thank you for your time and attention.
Thank you, Alex. So that was a longer talk, so we've only got time for one quick question, if anyone has a question. If there are no questions... Oh, there is one question over here. And, yes.
Hi, I'm Purna from University of Notre Dame. In the beginning, you said you asked the participants 2 questions. Do you ever do these things, and then how do you go about doing them? Do you have like the list of things you ask them? And
right. So as I said, the interview guide is a list of topics, and these were semi-structured conversational interviews. So what we did was we would broach each topic according to sort of a formulaic script, and then oftentimes there would be a resulting discussion in which we might ask follow-up questions to get at things that our interviewees thought were particularly important to our study.
How did you come up with the list of topics?
Mostly based on prior work on researcher degrees of freedom, what kinds of places in the analysis process a researcher has the opportunity to make decisions which impact subsequent results.
And they were not domain specific?
Not particularly, no.